You believe space is empty, don't you? A vast, silent canvas where galaxies blaze and black holes gorge. You walk through it, breathe it, measure it. It feels like the ultimate backdrop, the silent stage upon which all cosmic drama unfolds. But what if that feeling is the greatest illusion in the universe? What if space, the very fabric of reality, isn't a fundamental pre-existing void, but an emergent phenomenon? A grand cosmic trick of perception, woven from threads so impossibly small, so profoundly alien, that they defy all our intuition? What if the space between your own hands isn't truly empty, but a living, breathing quantum construct? Einstein's general relativity, the cosmic titan that sculpted our understanding of the universe for a century, paints space as a majestic, flowing ocean. It dictates that space is not a passive void, but an active participant, a dynamic, stretchy fabric that curves, warps, and bends under the monstrous weight of stars and galaxies. Gravity isn't some invisible force pulling objects together. It's the very geometry of this fabric, warped into a cosmic divot, guiding planets in their orbits. General relativity screams of elegance, of a universe where space and time are inextricably interwoven, a seamless, smooth tapestry upon which all reality unfolds. It is a symphony of cosmic order, where every celestial body plays its part by deforming the stage itself. But then another titan rises, roaring a completely different truth. Quantum mechanics, the physics of the infinitesimally small, the realm where particles pop into and out of existence, where certainty dissolves into a blur of probabilities. Quantum mechanics shatters general relativity's smooth, calm ocean, revealing a furious, roiling foam beneath. At these subatomic scales, space isn't empty or smooth. It's a chaotic maelstrom, a churning, effervescent soup of virtual particles constantly appearing and annihilating themselves. It's like trying to divide by zero on a cosmic scale. The numbers just explode into an incomprehensible turbulent mess. Where general relativity sees a calm, predictable surface, quantum mechanics reveals a violent, probabilistic froth. These two fundamental pillars of modern physics, each flawlessly describing its own domain, collide head-on at the very heart of reality. General relativity reigns supreme on the grand cosmic stage, dictating the dance of galaxies. But quantum mechanics rages in the microscopic theater of existence, governing the very atoms that compose those galaxies. They are utterly, terrifyingly incompatible. One demands a smooth, elegant continuum. The other insists on a pixelated, violent chaos. This isn't just a scientific disagreement. It's a profound, impossible conflict, leaving a gaping, terrifying chasm in our fundamental understanding of existence. How can space be both a silky bending sheet and a boiling probabilistic froth? The universe demands an answer. Now enter the universe's most mind-bending, spooky secret: quantum entanglement. Imagine two coins separated by light years. You flip one, and before it even lands, the other coin, instantly, across the vast cosmic gulf, knows how the first will land. Flip it again, and the distant coin flips too, mirroring its twin without any apparent communication. This isn't telepathy, it's entanglement, a bizarre fundamental connection where two particles, once linked, remain intimately bound, instantly sharing information, no matter how much space violently rips them apart. Einstein himself, unnerved by its implications, famously called it spooky action at a distance. It defies every shred of common sense, every law of local causality we hold dear. Think of it like this. You have two cosmic credit cards. They look identical, but they're intrinsically linked. When you use one to buy a star, the other card, instantly across billions of light years, shows the exact same transaction. There's no signal sent, no information exchanged across the void. The link is fundamental, instantaneous, and unbreakable. These entangled particles are like cosmic twins, born together, forever tethered by an invisible, non-local bond. Their fates are intertwined, their properties locked in an instantaneous dance, regardless of the staggering distances that may separate them. This isn't just a quirk of quantum mechanics. It's a profound, terrifying whisper from the universe itself, suggesting a deeper hidden wiring, beneath the apparent emptiness of space. This spooky action is not some theoretical fantasy. It's been proven repeatedly in laboratories across the globe. We can entangle photons, electrons, even small diamonds, and watch as their fates remain inextricably linked, even when separated by miles. The implications are staggering. If particles can be so intimately connected across vast distances, what does that say about the very nature of those distances? What if the distance itself is an illusion, a manifestation of the connection, rather than the other way around? This invisible tether, this non-local bond, hints at a universe far more interconnected than our classical minds can grasp. It suggests that the empty space we perceive might be teeming with these phantom connections, an unseen web of quantum threads. And here's where it gets truly wild. What if these unbreakable, instantaneous quantum connections aren't just in space, but actually are space? What if the fabric of our reality, the very dimensions we inhabit, is not a foundational entity, but an emergent property, a grand illusion woven from these entangled pairs? If you're finding this journey into the universe's most profound secrets as mind-bending as we are, punch that like button and subscribe for more cosmic mysteries. Your support fuels our explorations into the mind-shattering frontiers of reality. Now brace yourselves, because we're about to unveil a theory so audacious, so mind-bending. It feels like a cosmic punch to the gut. ER EPR. This isn't just a catchy acronym. It's a radical, desperate solution to the impossible conflict between Einstein's smooth spacetime and quantum mechanics' frenetic chaos. It's the universe's ultimate secret handshake, proposing that the very fabric of space, the distances between everything, might be stitched into existence by the ghostly threads of quantum entanglement. Let's break it down. EPR stands for Einstein-Podolsky-Rosen, the famous thought experiment that first highlighted entanglement's spooky action at a distance. It's the quantum connection, the invisible tether we just explored. ER stands for Einstein-Rosen, the scientific name for a wormhole. Those theoretical tunnels through space-time that could, in theory, connect two vastly distant points in the universe, or even two different universes. Think of a wormhole as a cosmic shortcut, a fold in the fabric of space that brings far-flung regions intimately close. You enter one mouth, and instantly, you're out the other, having traversed light years in a single step. For decades, these two concepts, quantum entanglement and wormholes, lived in separate theoretical kingdoms. One ruled the subatomic, the other the cosmic. They seemed utterly unrelated. But then, in 2013, theoretical physicists Juan Maldacena and Leonard Susskind dropped a cosmic bombshell. What if they are the same thing? What if every entangled pair of particles is, in essence, connected by an infinitesimally small, unseeable wormhole? This is the core of ER EPR. Entanglement is the wormhole. The quantum connection is the space-time tunnel. This isn't just a neat mathematical trick. It's a profound reimagining of reality. If ER EPR holds true, then the very act of two particles becoming entangled creates a tiny, ephemeral wormhole connecting them. And if space itself is composed of countless interacting particles, then the vast, seemingly empty expanse we perceive could be nothing more than the collective manifestation of billions upon billions of these tiny quantum wormholes, constantly forming and dissolving, stitching the cosmos together. Imagine a colossal, invisible quilt, where each stitch is an entangled pair, and the fabric itself is the space we inhabit. This theory suggests that space is not fundamental, but emergent. It doesn't just exist, it arises from something deeper. It's like the image on your computer screen. The picture isn't fundamental. It emerges from millions of tiny pixels. In the ER EPR universe, space emerges from the quantum pixels of entanglement. The distance between 2 points isn't an inherent property of the void. It's a measure of the entanglement density, the complexity of the quantum connections between them. A highly entangled system would be closer in this sense, even if it appears far away in our classical perception. This radical idea redefines gravity itself, no longer a force, but a consequence of the geometry created by these quantum stitches. When massive objects bend space-time, they're essentially altering the distribution and strength of the underlying entanglement, changing how these cosmic threads are woven. It's a universe where the ultimate reality is not solid ground, but an intricate, dynamic, and profoundly interconnected quantum weave. If space truly isn't fundamental, if it's merely an emergent phenomenon woven from quantum entanglement, then the implications are nothing short of terrifying. What happens when the quantum stitches fray? What happens when these invisible threads that bind reality together begin to unravel? This isn't just abstract physics. It's a dizzying plunge into the nature of existence itself. First, consider the universe's most ominous monsters, black holes. For decades, they've guarded a cosmic secret that tears at the very heart of physics, the black hole information paradox. When matter plunges into a black hole, it seems to vanish forever, its information supposedly destroyed. But quantum mechanics screams that information can never truly be lost. It's a fundamental law. ER EPR offers a radical escape. If the matter falling into a black hole becomes maximally entangled with the Hawking radiation it emits, then the wormholes connecting them prevent information from ever truly being lost. The black hole isn't destroying information, it's just routing it through a quantum tunnel to the outside, preserving the universe's cosmic ledger. The paradox, which has tormented physicists for decades, might simply dissolve if space is a quantum weave. But the theory also introduces new, chilling possibilities. If space is pixelated at its most fundamental level, arising from these quantum connections, then at extremely small scales, it wouldn't be smooth at all. It would be frothy, foamy, like a constantly boiling pot of microscopic bubbles. This quantum foam could mean that our smooth, predictable reality breaks down at the Planck scale, a realm so tiny it makes an atom look like a galaxy. Navigation through such a frothing reality would be impossible, and the very concept of distance would shatter. It's like trying to walk on water when the water itself is constantly exploding into mist and reforming. Furthermore, if entanglement is the loom upon which space is woven, what happens if that entanglement is somehow destroyed or disrupted? Could regions of space simply dissolve? Could the universe itself, at its deepest level, be prone to cosmic rips and tears if its quantum foundation breaks? This raises the terrifying specter of space-time defects, regions where the quantum stitches have failed, leaving behind gaps or anomalies in the fabric of reality itself. These wouldn't be mere voids. They would be regions where the concept of space as we understand it ceases to exist. This emergent space-time also offers a radical new perspective on the Big Bang. Instead of a singular point of infinite density and heat, a cosmic computer dividing by zero, the Big Bang could be reimagined as a phase transition, the moment when the universe's fundamental quantum threads first began to weave into the larger classical fabric of space we observe today. It might not have been a point in space, but the very birth of space itself from a primordial entangled state. This transforms the Big Bang from an inexplicable cosmic explosion into a grand quantum unfolding. The implications ripple through every corner of cosmology. Dark energy, the mysterious force that pushes the universe apart, might be a manifestation of the vacuum energy within this quantum foam, constantly generating new entanglement, creating more space. Dark matter, the invisible scaffolding of galaxies, might be a different kind of entanglement, a more stable, less dynamic weave. The very nature of what we call empty space changes from a featureless void to a dynamic, living, breathing quantum tapestry, constantly shifting and evolving beneath the visible cosmos. It forces us to confront the possibility that the universe is not built on solid ground, but on an incredibly complex, constantly reweaving quantum illusion, fragile and magnificent all at once. Our journey through the cosmos has brought us to a startling, humbling truth. The space around us, the seemingly immutable backdrop of our existence, might be the universe's most profound illusion. We began by grappling with the impossible chasm between Einstein's smooth, elegant spacetime and the furious, probabilistic chaos of the quantum realm. We then plunged into the spooky action of quantum entanglement, that invisible, instantaneous tether, binding particles across impossible distances. And finally, we dared to confront the radical hypothesis that entanglement is the wormhole, that the very fabric of reality is not fundamental, but woven from these phantom connections, a grand, dynamic tapestry stitched from quantum threads. This isn't just a scientific theory, it's a reimagining of what it means to exist. If space is emergent, then reality is far stranger, far more interconnected, and profoundly more alive than we could ever have conceived. It means the universe isn't a static stage, but a constantly reweaving, dynamic dance of quantum connections. This knowledge evokes a potent mix of awe at the universe's elegant, terrifying complexity, and a touch of existential dread at the thought of a reality that could, at its most fundamental level, fray or dissolve. Yet this very fragility makes our present cosmic golden age all the more precious, a fleeting moment where consciousness and complexity stand as remarkable victories over entropy and isolation. The human quest to unravel these deepest secrets continues. The questions rage: what is dark energy? How did cosmic structure truly form? What is the ultimate fate of consciousness in an expanding, potentially unraveling universe? The theory of emergent spacetime, stitched from quantum entanglement, stands as a testament to our insatiable curiosity, pushing the boundaries of what we thought possible. It awaits our future explorations, holding within its elegant, terrifying framework the keys to understanding forces and phenomena that operate on scales from the infinitesimally small to the unimaginably vast. In the quantum weave, we find not just physics, but poetry, not just answers, but the presence of the universe's most profound mysteries. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.